This video is going to cover Math 112. If you are a UMA student, it's section 4.1. If you're a Monmouth Academy student, it's section 3.5. But the topic is higher degree polynomials. The degree of a polynomial is the highest exponent. So you can have a whole bunch of exponents, but we only talk about the highest one. The leading coefficient is the coefficient or the number on the term with the highest exponent. And then the constant term has no variable. So if we look at a cubic, our degree would be 3, because that's the highest term. The A would be the coefficient, the leading coefficient, because it's on that term. And the D is the constant, because there's no x with it. On a quartic function, the degree is 4. Our leading coefficient would be A, because it's with the x to the 4th. And the constant would be E, because it has no x. We have another function capsule here. So this can go on your paper if you want. Quartic function, f to x to the 4th. Now, if it's not the parent function, if it has like other terms, it could end up looking like this. But the parent function flattens out. Looking at that, the domain is negative infinity to infinity. It goes up forever and flattens out at 0. So the range is 0 to infinity. It is increasing on the right-hand side. So from 0 to infinity. It is decreasing on the left-hand side. So negative infinity to 0. There's no break in the graph, so it is continuous from negative infinity to infinity. And it's symmetrical at the y-axis, so it's even. Now, extrema or extremes are your max and mins, any bumps. So a local extreme is any bump. This is a local, this is a local, this is a local, this is a local, this is a local. Any bump. Global is the highest or lowest on the entire graph. So let's look at these. A local max, so any bump at the top. CD would be a local max. IJ would be a local max. Local minimums are the bottom bumps. So we have AB, we have EF, and we have GH. Those are all local minimums. The absolute or global max is if it's the highest point on the whole graph. So on this graph, this goes up forever. There's no point higher, or there's a point higher than CD. So CD is not global. Same thing on this graph. It goes up forever. So there's no global max. Now let's look at our minimums. On this graph, it goes down forever. So there's a point lower. But on this graph, it's never below EF. So because both ends go up, EF is also considered an absolute minimum because there's no point lower. Hidden behavior. So this is any behavior that you can't see based on the window of your graph. So you want to play with the window settings or your zoom settings to make sure you see any hidden behavior. Oh, goodness, I hit a button. Entire graph. So on one graph, maybe the way it's set up, it looks like this. But if you zoom in really close to like this part right here, maybe it looks like this. So you want to make sure you're zooming in to see all of those parts. End behavior. So that's just looking at the ends of the graph. We don't care about the middle. We don't care about any of these bumps. We only care about the ends. In odd degree, so if your highest exponent is an odd number and your leading coefficient is positive, the left end is going to go down, the right end is going to go up. If the leading coefficient is negative, that switches. So your end behavior looks like that. If it's even, the ends do the same thing. So if your coefficient is positive, the ends both point up. If your coefficient is negative, the ends both point down. So let's look at A. Our degree is 4, that's even. And the number in front here would be 1, which is positive. So the ends would go like this. Meaning, whatever happened on that graph, it could go like this, but the ends are both pointing up. We don't know anything about the middle, just the ends. Now let's look at B. B is 6, so that's even. The leading coefficient is -1, so our ends would both point down. This would be enough to write for your end behavior. C, we have odd, and 3 is positive, so we would write down then up. Here we have odd and a negative, so we would write up then down. And that's all you have to write for the symbols. If you are asked for real zeros or solutions, those are the same as the x-intercepts. The number of x-intercepts on a graph are less than or equal to the degree. So if your degree is 4, you will have 4 or fewer x-intercepts. If the degree is 3, you will have 3 or fewer x-intercepts. If your degree is 8, you'll have 8 or fewer. That's always true. On a graphing calculator, so we're going to put this in Y1. Y1. So I'm going to clear all these out. Okay. X cubed, and so I can do that caret button over here for cubed. Arrow down, plus 5x squared plus 5x minus 2. And I'm going to zoom 6. So here I can see intercepts, I can see max and mins. So let's find our x-intercepts. So I'm going to start by looking for this one. So you hit second, and then you hit trace, and you go down to 0. That's our x-intercept. Then it says left, so you go to the left of that intercept. You go to the right of that intercept. Your calculator may ask you to guess, and then it tells you that value. So negative 3.3 is going to be one of those zeros. Then you do that again for the other two. Second, trace 0, and you go to the left, to the right, and guess. This one's negative 2. And then if I do it again on that last one, left, right, guess, and this one's going to be 0.3. So those would be the 3 x-intercepts, or the 3 solutions, or the 3 zeros of this equation. When you are asked to analyze, we're going to look at the graph and we're going to figure things out. So if it's 5, 4, 3, 2, 1, 0, we know it's odd because that's a 5. So we know, and that's a positive 1. So we know one end is going to go up, one end is going to go down. That makes the domain and range both negative infinity to infinity. Extremes are going to be the bumps. So we would have to put that in the graph. So let's stick it in our calculator. X to the 5th plus 2x to the 4th minus x to the 3rd. Oh, I kept going. X to the 5th plus 2x to the 4th minus x to the 3rd plus x squared minus x minus x minus 4. Hit graph. So then we would look at this picture and we would be able to find our maximums and minimums using our second trace max and min. It goes up and down, so there's no absolutes, just the locals. And then we can find the x-intercepts using zeros. So that's what you're doing there. Now, the last thing is a comprehensive graph shows all x and y intercepts, all max and mins, and the ends. So you want to be zoomed in enough that you can see every bump, every intercept, and what it's doing at the end. If the graph goes like this, but you're only zoomed into this part, you're not seeing everything. So if it says comprehensive, it just wants all of that. Finally, if we're going to get a bunch of points and graph a curve, we're going to enter these. So that's L1 and that's L2. So we're going to, in our calculator, we're going to enter those. So we hit Stat, Edit, and then we're going to type these in L1. So 1, 2, 3, 4, 5, all the way to 12. If there's more data, we can just delete it. And then here we have 69, 70, 75, 80, 85, 88, 90, 89, 87, 81, 76, and 70. So once those are in there, we're going to try and figure out what kind of equation would be good. So if I hit Stat and I arrow over to Calc, I have a bunch of options. Number 4 is linear regression. So we're going to try that. We're going to try number 4. And we just want our X list and Y list to match L1 and L2. Hit Enter. And we get a bunch of decimals if I do that. R squared for our lin reg is 0.06. So that means only 6% of it is explained by the line. So that's probably not very good. So let's try again. Stat, over to Calc, we'll choose number 5, the quadratic reg. And if I do that, I get an R squared of 0.93. If I do it again, Stat, Calc 6, and I do cubic, I get an R squared of 0.97. If I do it again with 7 for the quartic, I get an R squared of 0.998 on. So that's going to be the highest one. So that's what we're going to use. We want the highest percentage explained. So 0.998 is bigger than all the others. So we know it's quartic. So it's going to have an x to the 4th. It's going to have an x to the 3rd. It's going to have an x squared. It's going to have an x, and it's going to have a constant. A goes with our x to the 4th. B goes with our x cubed. C goes with x squared. D goes with x, and then E is our constant. So that would be the equation that models the lines. And you can do that with any different piece. So that is section 3.5 or 4.1. Let me know if you have any questions.